and wish everyone a happy garbage day for the last time this semester, at least in this class. I'll wish the next class a happy garbage day too, because that's how I roll. It's Tuesday. We have 1 week of classes left. We'll see how far we get with the material that I have prepared, and if I don't get through all of it, I'll make a video on my own so that you have something to go back to besides just the resources. I have in front of me our course webpage to point out a couple of things. So first off, I updated the printable version of the syllabus in PDF format, so to reflect what actually happened throughout the semester as opposed to what I had planned. I do this for 2 reasons. For future Lisa, when I'm planning the class next time, to remind myself not to pack in so much and realize how much I actually could cover in the span of 1 semester. But also in case any of you need to show a syllabus to someone to demonstrate that you've had coursework given this material, then it's a nice finalized version as to everything that we covered. So that is available for you. Let's see, scrolling all the way down to the end of the boxes. I never thought we'd get there, but we did. We have Formative Assessment 5 to discuss today, one of my personal favorites, based on a true story. Lecture 9 to keep going with, and Example 9. So we should have all of those files. Next week, oh wait, one more thing. I did turn back your homework 5, if you gave it to me. That is, not everyone has finished it yet, which is okay. If you haven't finished it though, please, if you want a chance to revise, try to get it to me by Friday. I will promise to turn it around over the weekend, get it back to you on Monday so that you've got all next week to make a revision. If it comes in later than that, I will accept it, but I can't guarantee enough time to where I can actually grade it and give you meaningful feedback and time to revise. So it's up to you. If you look at your score and you're like, yeah, you can keep your 1/4 of a point, Lisa, I don't need to worry about this anymore, and you don't want to revise, it's fine. It's up to you. But I like to give opportunities for mastery. Not everyone's models cooperated, for instance. Some of you ran into convergence problems or other kinds of error messages that you're trying to troubleshoot, so I'm happy to keep working with you to get to a point where you're happy with that work. Finals week, I've made an executive decision that the TAs are not holding office hours, okay? They have their own stuff to do as well, so I'm not even gonna ask. But I'm gonna have office hours. Mondays I need to move, however, so Monday of next week, finals week, I'm gonna have office hours from 1 to 2:30 instead. Our department is undergoing an external review, which is something we have to do every either 5 or 7 years, and we're supposed to be in meetings during the time that I would normally have office hours, so I need to move those. Otherwise, I will have office hours when I would normally be teaching or in office hours Monday through Thursday. I'll be on email. I know everyone's trying to get stuff wrapped up, and I want to help you get there. So everything needs to be submitted Friday. I will work on finishing grading and updating everything, and then I will let you know when grades have been submitted, hopefully within a couple days after that, which is what we're supposed to do. I did update grades this morning, so you should be able to look at your point totals inside the homework portal and see where you are at with respect to all the work that has been due thus far. I don't have the points included for homework 6 since that's not due just yet. So, any questions on any of that? Okay then, it's one of my favorite points in the semester. It's time to play Let's Make a Deal. Those of you who've been in my courses before know what's coming. But last week, you would have received an invitation to complete a course evaluation through the University of Iowa. And I have up here our current totals. 8 out of 20 of you in this class have completed one. And you'll note my totals for the previous semesters are extraordinarily high. Do you know why that is? Because I bribe people to do it. Excuse me, I give you additional compensation for your out-of-class efforts. It's not a bribe. I would like to offer the class a deal. There are 20 of you. If at least 18 of you complete a university course evaluation, everybody gets a point of extra credit in the numerator, but not the denominator. So bug your friends, nag folks if you need to. I cannot see who has completed it and who hasn't, but I have the capability to send a reminder, as you can see here, that will automatically figure out who needs a reminder. So I will do that on Friday just to make sure, but if you can get these done by Saturday, that's when they close at midnight, then we'll have a chance to get that feedback. In addition to that, because these questions are generic and honestly not super useful to me in planning how to change the course, I also supplement university course evaluations with a custom Qualtrics survey for each class that I teach. You will get an invitation to complete that survey tomorrow morning, and everyone who does it gets a point extra credit themselves. You don't have to worry about response rates. The way it works is that I feed it a list of emails, and then on the back end, it tells me which email addresses have completed a survey. But it does not link your responses to your name, so it is still anonymous in that regard. So I'm asking for more specific feedback about different aspects of the course, as well as your experiences with the TAs, so they can get some feedback as well. And I very much would appreciate it if you would take the time to complete both of those evaluation activities. I do make changes. I've had some really good ideas in the past that have been given to me through this mechanism, so I look forward to seeing what you come up with. This is like the one point in which I really consider myself a qualitative researcher, right? Because the open-ended questions are much more informative as to how to change things than how much did you like this? Because I didn't like it doesn't tell me what to do from there. But specific reasons why you did or did not like something are always valuable. So that's my deal, okay? To recap, university course evaluations due Saturday. If at least 18 of you do one, the whole class gets a point of extra credit. The Qualtrics survey you will get an invitation to tomorrow morning. That runs until the end of finals week, so you can complete that with more time to spare. And anyone who does that gets a second point of extra credit. So, what do you think? Fair? Okay, that's my deal. I will let you know on Thursday how these things progress. So no homework 6 questions. We did that one. Discussing again. We do have then formative assessment number 5 to talk about. I read through your answers this morning and had lots of good feedback. Some of you mentioned that you weren't exactly sure what the reviewer was saying. Join the club. That happens quite a bit. People's comments are not always obvious in terms of their intent, in which case I try to answer the question I thought they asked, or the question that I wanted to answer, just like a politician, right? You watch political debates, sometimes they don't answer the question, they answer a different question. So I reserve the right to do that as well. But this series of questions is based on a true story. I literally pasted in comments from reviewers. I masked some identifying details, but otherwise this is a true story. And the conclusion to the story is that the paper was eventually published. So we were successful in arguing against reviewer 3. So it has a happy ending to the story. But I'd like for you to start thinking about these things at a higher level, because you will be in the position of having to answer criticisms or defend your methodology, and I want you to be able to do that in the context of measurement models. So the background of the story then, we did confirmatory measurement modeling on a scale that had previously only had alphas and exploratory analyses done to examine its factor structure. It had 21 items measuring 3 traits, so 7 items apiece. Something related to psychology is enough detail you need there. The item response format had 7 different points. However, because of the nature of the trait, the responses were skewed. So the idea that the responses are continuous enough or normal enough to be fitted to a CFA is somewhat debatable. So to cover our bases, we decided to do the exact same series of models and reporting with a CFA framework in which we're pretending the item responses are continuous and they have a linear relationship to the latent trait, and an IFA framework in which it's an ordinal model, and we used limited information WLSMV estimation so that we could get the same measures of fit both ways. So, and the entire results section was structured like CFA, IFA, blah, CFA, IFA, blah. So it was all very much interwoven with explanatory text trying to describe what the differences between the models were, as well as why we did everything 2 different ways. We converted the IFA parameters to IRT versions, so we have the same types of plots that I had you make in Homework 5 with respect to the spread of difficulty across the response choices. And we also had a plot that showed the prediction from test information in a reliability metric, so 0 to 1 instead. And we reported omega instead for CFA, I believe also factor score reliability if memory serves, and then information as a function for IFA. So that's the backstory that these questions are based on. So any questions about that or comments on the backstory?
I have a question on the backstory.
Yeah.
So because I see the reviewers keep mentioning rash model. So in the model you have, did you have like equal loadings for the CFA, for the IFA models?
Great question. We did not. So this is a separate loadings model for both the IFA and the CFA.
Okay, thank you. I was wondering why they keep mentioning Raj.
That's a great question, and I don't know the answer to that. But clearly, that's someone who was trained from a different perspective, and that was the vocabulary that they learned. So then the question is, how do we make sure we're talking about either the same thing or different things? A lot of this is just wording issues and confusion with respect to how to describe models, I think. Any other questions before we dive in? All right, then. So question or comment number 1. WLSMV and the theta parameterization are not typical IRT models. It is true that you can reparameterize as an IRT model, but effectively you are looking at the same model. To conduct a proper IRT-based analysis, it is likely necessary to also look at Roche parameterizations and spacing of answers. So I can tell you that this last comment is specific to, my guess is, a computer program called WinSteps that is a Roche modeling IRT package, and one of the pieces of output that it provides for a partial credit model is this mapping of choices to the continuum. So it will tell you, like, 1 versus 2 is here, 2 versus 3 is here, 3 versus 4 is here, and then they have little dots for where your people are. So I think that is the picture that was in this person's mind when they asked the question. But how do we respond to this? You all answered the question, so feel free to read your responses aloud or come up with new ones, your call. Or paste them into the chat. Faster that way. Well, let's break it into pieces. How about the first part? WLSMV and the theta parameterization are not typical IRT models. I'm actually going to agree with that. What is WLSMV? Is it a model? What is it?
Estimation method.
Yeah, it's a method of estimation, meaning a way of finding the answers. So I will give them that WLSMV is not a typical IRT model because it is not a model. From an IRT perspective, that phrase typically goes along with the use of full information maximum likelihood, or Bayesian estimation, which is full information maximum likelihood plus priors for all of the parameters. So it is somewhat atypical if you're coming at this from a Roche modeling IRT perspective. WLSMV is much more of a factor analytic, like that world would be more familiar with this. And people who use WLSMV would call their model either an item factor analysis model, a CFA for categorical outcomes, an ordinal factor model, or potentially a nonlinear factor model. That's another phrase that you can add to your collection of these things. By the way, the theta parameterization, that refers to your method of identification for the continuous underlying variable for these ordinal responses that you don't actually have. Theta says the residual variance of your pretend underlying continuous variable is 1. The default method for most models in M+ is the alternative, which is called delta, in which the total variance of the pretend underlying continuous variable is 1 instead. So something's got to be 1. They got to nail it down somehow to make this work. I use the theta parameterization because it's consistent with the probit link function when you phrase it that way. So I like it that way. Okay, so yeah, they're not typical IRT models. They're typical estimators instead. It is true that you can reparameterize as an IRT model. True or false? What do you think about that? Can item factor analysis models be reparameterized as an IRT model? Yeah, y'all did that in your last homework, right? I made you. Reparameterize, by the way, is a big word that means rearrange. The difference is in which item parameters you get. IFA is usually phrased as loadings and either intercepts or thresholds, and IRT is phrased as A's and B's, in these models potentially adding on C's and other things as well in other cases. But effectively, you are looking at the same model. Okay, we're in agreement. To conduct a proper IRT-based analysis, it is likely necessary to also look at Roche parameterizations and spacing. Now, most of you picked up on this. What do you think? Is it likely necessary to also look at Roche parameterizations? Got some head shakes. Zoomers, what do you think? Now, what's a Roche model, folks? Or the Roche family of models? We got a quote here, concerning the Roche parameterization, we will test the Roche model and compare it to our model. In the likely event that our model is a statistically significant improvement, yeah, it's going to happen. We will note the Roche comparison in a footnote. Yes. So Roche is a family of models, but the common denominator of that family is equal loadings, equal discriminations, equal A parameters. So they're asking, I think, to test our model against a model that has all of the slopes constrained to be equal across items. We would call that tau equivalent in the CFA literature. We would call it a Roche version of an IFA model. And if I'm using WLSMV, what do I need to do to make that comparison? Is that a likelihood ratio test? Nope. What is it instead? Yeah, it's called diff test and M+. Is it still ANOVA and Levon, folks, who did it that way? I'm trying to remember. I feel like it is, maybe. Vladimir, do you know?
I don't think so.
No?
I don't remember.
I don't remember. It's in my materials. Someone look through examples and tell me what it is. But I want to say that it's still related, but it didn't come up with the same answers as what diff test did. So there's something in the programming that makes it different. So yeah, this is the part of the question that I chose to answer. Sure, I'll compare it to a Roche model. That's a model comparison because a model that has one slope for all the items is nested within a model that has different slopes for each item. And to the extent that the model, that the test is significant, which one wins? It was, by the way. It's always going to be in psychological type data. It always is going to be. So which one should I use if the diff test is significant in this context? Yep, the one with more parameters. Okay, this is a general answer. If you do a model comparison and it's significant, the bigger model is better or the smaller model is worse, whichever way you want to talk about it. That is a general rule you can take with you. If the test is not significant, then I would say the bigger model is not better, the smaller model is not worse. But in an absolute fit sense, when you add parameters, you should be improving fit. If you take parameters away, you should be hurting fit. The question is by how much? Spacing of answer options, I already did that. I made a picture that specifically spoke to that because one of the things that I was interested in is, do you really need all 7 response categories? See, that might be overkill in terms of levels of agreement or frequency of behaviors or things like that. So I was okay with that one, fine. And I forget to mention it, but also the usual, thank you for your consideration of our results. You always say thank you. And if they don't understand something, you apologize. It's not their fault. We apologize for being unclear. Always. All right, any other comments or questions, reactions to this one? So yeah, if someone tells you that you need a Roche model instead, they are asking you to test whether you need different slopes. That is my interpretation. In terms of polytomous data like these ones, so an ordinal response format, a Roche family does not have the graded response model like you guys know it. The ordinal cumulative model is not within the Roche family. What they have is something called the partial credit model, which is an adjacent category link. So that's the one where it's 1 versus 2, 2 versus 3, 3 versus 4, as opposed to 0, 1, 2 versus 3, 4, 5. Cumulative lumps everything together and enforces order across the category responses. The partial credit model, which is within the Roche family, does not. So it's only adjacent. And it does not have, by the way, the partial credit model does not have an analog of limited information estimation. It can't, because it's not described by a continuous distribution that's been cut up, which is essentially what we're saying about ordinal data. Okay. Ready for the next one? Why not? So, respond, revise the paper, comes back. The artificial difference between IRT, item factor analysis, and CFA, missing the Oxford comma, by the way, one of my pet peeves, is still methodologically problematic. These models are fundamentally nested in each other. So, artificial difference between followed by a list of 3 things, also not grammatical, should be among. Not that I'm nitpicky or anything. These 2, are they different? IRT and item factor analysis?
No.
No, they'll generate the same predicted probabilities. They'll just do it through a different set of parameters. So I'll give you that one. How about IRT/IFA and CFA? Are they different?
Yes.
Yeah, what makes them different?
CFA is assuming that our item response is continuous and normal, while in IFA we understand that they are discrete categorically.
Exactly. CFA is analogous to a linear regression model. It is for continuous item responses where there is a linear relationship between the factor in predicting those continuous item responses, and it uses a conditional normal distribution accordingly. IRT and IFA is an ordinal regression model. So they use cumulative link functions, either logit or probit, conditional multinomial distributions, and they don't have any kind of assumptions of normality with respect to the outcomes, just with respect to the factors, which is still the case for CFA as well. So these are fundamentally different models. Like if you were to use full information maximum likelihood and try to estimate both sets, those likelihood functions would be on different scales because they're using different distributions of height. The IFA world would use a multinomial distribution as its definition of height, whereas CFA is using normal as its definition of height. It's like Celsius and Fahrenheit. They're not like, they're not the same. Celsius and Fahrenheit you can get from one to the other though. So I need to pick a better one. Apples and oranges? Brownies and strawberries, maybe? Trying to go for something that's in the same family, but it's not the same. Yeah. What about nested? These models, presumably all 3 somehow, are fundamentally nested in each other. What do we think about that? Yes for thumbs up, no for thumbs down. We got 3 thumbs down. Bunch of people on the fence, it looks like. What's a nested model? Like if you were to describe it in more general terms, because that's a phrase that comes up all over the place. What's a nested model? How do you know if you have 2 nested models? One nested in the other.
The smaller one has to be contained within the bigger one, and there has to be a smaller one and a bigger one. Like it has to, you have to have that. If they're
Exactly.
the same number, then they're not nested within each other.
So in this case, nested models, give me examples you've learned to do nested model comparisons in this class. Let's leave the reviewer alone for a minute. Think of some examples. We've done several kinds.
1PL and 2PL.
1PL and 2PL, whether a Roche model is sufficient or whether we need different slopes. Yep. Whether you should have error covariances, more than one. So the model with the error covariances is the bigger one. The one without them is the nested model. What about how many factors you have? 1 factor versus 2 factor? That one is nested, actually, because the way you can think about it is that a 1 factor model says the correlation between the 2 factors is perfect. It's 1. So what you're adding is the ability of that factor correlation to go off of 1 to become something smaller. So that makes them nested, even though it's not as obvious. What about all of measurement invariance and differential item functioning? All the things different, all the same, all the same, all the same. It's a whole series of nested model comparisons. But the common denominator in all of those examples is that you're starting from the same kind of model in the first place. Like CFA world, invariance, nested. IFA world, differential item functioning, nested, right? It's the same. IRT and IFA are not nested with respect to CFA or either way. They're not non-nested either, just like 2 different families of models. They're not the same. So that is just incorrect, and I believe that was what my response said. I may be misinterpreting the reviewer's comment. However, I do not believe these models are fundamentally nested in each other. See citation, citation, citation of every other measurement book. Comment 2, regarding the plot of test information converted to reliability. Reliability as a construct does not exist at the person level, only at the sample level. Constructs like person reliability need to be defined and then still do not make that much sense because they are not identical to the empirical IRT reliability that should be reported, and the authors should show the person SE, standard error. What do we think about this? So in CFA, how would we think about reliability? What would we do? What would we report? I'm gonna start cold calling on people. What would we report, Erica? Omega, that would be reliability of a sum score using the information from the confirmatory factor model, so the loadings, the error variances, error covariances, and so forth. Also factor score reliability we could do. And is omega going to be one number or a function? In CFA.
One
Good.
number.
Yeah, it's one number if it's a straight line function, if that's the case. And that's because of the linearity. It's the relationship between the factor and the item response is linear. That means if it's a good item, it's good the whole way along theta. So the information function that each item would contribute is a flat line. So they differ in height as to how much information is there, but it's not like it shuts off at some point on the continuum because a linear slope keeps going forever. In contrast, we have information functions in IRT because of the non-linear relationship. We have that S-shaped curve, item characteristic curves. So that means each item is only useful for part of the theta continuum. It contributes information in that part, but then it shuts off as it moves away. So you can't have one number from an IRT model to describe composite reliability without somehow weighting across all the people and all the different thetas. But I would argue that doesn't make a lot of sense because then you can end up with a false picture. If you're measuring low people really badly and high people really well, then like saying, oh, I have medium reliability would not give you enough information to improve your reliability. I think it would not be useful. What about, I should show the person SE? Is that a reasonable request? You'll see that in IRT textbooks. You'll see a function of person standard errors as across theta. Do I already have that somehow? Or a version of it? Yep. Standard errors and information are the opposite of each other. Test information equals 1 over the standard error squared. So I had an information function, and they wanted a standard error function. And I'm like, all right, it'll just be the opposite, right? Get your curve, it's going to go this way instead. But I would say that that is kind of like person reliability in that it's theta specific, how much information you have at a particular point, but it's not in that each person would not have a different standard error at that point. Like anybody at the same level of theta should have the same standard error, with one exception. When might that not be true? Any guesses? We haven't talked about this. When might you be less sure of a person's trait estimate? Even after controlling for how much information the items tell you about it.
Is it when we do not have enough items to measure the person?
Not enough items, not enough answers. They didn't answer all the questions, right? Missing data would increase the standard error across the board because if you have less information from that person, you have less of a good answer as to what their theta would be. So yeah, we can add a standard error curve under a complete data assumption, which this largely was within this study. So yeah, that was my answer to this one. All right, I'll give you a person standard error curve and I'll put it in the same plot. It's going the wrong way, same thing.
So I have a question. What is the empirical IRT reliability that the reviewer is asking for?
Empirical IRT reliability, I have no idea. My best guess is that it is the weighted version. So there are ways to come up with a single number rather than a function, and essentially what you do is weight the amount of reliability at each point by the number of people at that point, and then you sum it all up and add it together. There are ways to do that. I don't think they're useful, but that's my best guess as to what they're talking about. Anyone else
Thank
know?
you.
No, anyone from the IRT class? Is this a thing you learned about, empirical IRT reliability? Nope, they're shaking their heads too. Yeah, none of us knows. So I showed the SE. I'm like, all right, fine. Also not nested. Then it comes back again. Now they are cooking with gas. Apparently they've gotten the M+ manual out and have learned a few things. CFA models are designed to predict a continuous, normally distributed item response. That's a quote. This is not really true, as ordinal CFA is a standard method. Yeah, it is. I'm glad we see eye to eye on this now. So ordinal CFA, CFA for categorical indicators, that's IFA or IRT. Those are models. Okay. WLSMV and MLR are both CFA methods. What do we think of that?
The estimation methods.
Yeah, they're estimation methods. However, traditional confirmatory factor analysis does not have WLSMV. That's not a thing. Like M+ will be like, we don't have this estimator for that. You would just be, you can have weighted least squares or generalized least squares as alternative to maximum likelihood for limited information on that, but not this one in particular. MLR, that's an estimation method. Is that just for CFA? Or could you use it on IFA and IRT too?
I was thinking it's just for CFA.
Well, the R part is referring to deviations from multivariate normality. And if you're not assuming that in the first place, then it reduces to regular flavor maximum likelihood. So the R is overkill, I think, in an IRT model or an IFA model, but it is a full information estimator. One is designed for ordinal responses and the other is mainly for continuous responses. I'm going to disagree on that. But MLR and M+ can also deal with ordinal responses in recent versions. So I see this a lot, and MLR can help to a point, but MLR does not change the linear relationship between the trait and the outcome. That is the issue. CFA models can predict responses to go out of bounds because a linear slope does need to shut off if you have bounded data. And then the user just needs to use the categorical option. Any guesses as to how my response was? Yeah, that is IRT and IFA. I believe my initial response was, yeah, no shit, Sherlock, what do you think I've been doing for the last 6 months? That's a technical term. I believe that is a reference to Sherlock Holmes, the famous detective. So yeah, we use the categorical option. That's what turns it into an ordinal model in the first place. Omega reliability does not make sense for a unidimensional factor model.
So please, I have a question.
Say that?
If you are using, I have a question. If you are using categorical, we are already saying that we want to go in the direction of IFA in M+, and then do we still need to use MLR in that case?
If all you're fitting is a measurement model and all of the responses are being treated as categorical, then no, you shouldn't need the R part.
Okay, thank you.
Yeah, if you have other stuff in the model, like once you get into a structural equation model and you have some continuous variables that may not have normal residuals or normal marginal distributions if they're predictors, then yeah, maybe. But you wouldn't it would be overkill. That is not an option within traditional IRT packages. It's just ML, or marginal maximum likelihood as it's called. So omega reliability does not make sense for a unidimensional factor model. What do we think about that one? I would say tell that to Rod McDonald, Greg Hancock, all of the other people who've done work on this and have declared it to be the optimal way of assessing reliability for a unidimensional factor model with sum scores. That's just patently untrue. So this is another one where you throw a bunch of references at them. And then last but not least, for an IRT model, there is only a unidimensional latent trait. Can you have more than one latent trait in an IRT model? Most of you are like, I just did. Does it go well? Necessarily? Yeah, some of you are like, yeah, it didn't go well. I showed you my error messages. Or it said, you have 8 million quadrature points. No, I'm not going to do this. Some of you got those error messages. So it is not true that IRT only is unidimensional. There is a whole field called multidimensional item response theory, and any kind of factor model that you could fit in a CFA framework, you can probably fit in an IRT framework. The only question is whether adaptive quadrature is going to allow it to be possible, in which case you would switch methods of estimation. But if we had a single trait, in which case Cronbach's alpha, omega, and the IRT reliability are all the same for a Roche model. Number one, do I have a Roche model? No. But if I did have a Roche model with equal loadings, are they right? Partially. Alpha and omega. Omega adds different loadings and potential error covariances. If you have a model in which the loadings are all the same, with no error covariances, then alpha and omega are indeed the same thing. But in an IRT model, omega needs to differ. So we don't do omegas for IRT models. People do alphas, but that is also inconsistent. And whatever this thing is, I don't know what that is. But by this point, I think the editor was more fed up than I was, because the decision came back very quickly after I said no, no, no. And it's published, so the end. So yeah, a lot of words. I feel like this is where the disconnects happen, is like, what do people call things, and are we talking about the same thing or not? So that is why in your homeworks, I wanted you to make a point of using the words and describing the model and how it's parameterized, because if somebody doesn't use the same words as you, but you describe the ordinal submodels and how they work, they'll know what you're doing. And if you tell them what estimator you're using, that should help fill in the blanks as to what you're referring to. One thing that I wanted to show you real quick. So in your revisions, I had asked you to use track changes. I want to make sure all of you know how to do that. I've had a couple questions on this. So in Word, for instance, under Reviewing pane, there's a button called Track Changes. When you turn that on, then any words you add are automatically marked so that I can see where you changed it. So in revising manuscripts, sometimes journals want you to do this specifically to make the job easier on the reviewers, because then they just orient to the changed parts. I would like you to also leave in my comments so that I don't penalize you for anything I didn't catch the first time. Like if you did something and I forgot to yell at you about it, then I can't yell at you about it on the revision. That's my goal. Another thing that I wanted to show folks is how to make subscripts. There were 2 people who made subscripts in their ordinal submodel equations. Thank you to the 2 of you. Everyone else did not. They just copied it in and put it the way it was. So I want to show you 2 different ways here, making this big. So for instance, YIS greater than 1 for a submodel equals, that's not right. These need to be subscripts. So you can either do it with a keyboard shortcut. It's Control equal, makes them subscripts when it's just straight text. By the way, to make them superscripts is Control Shift equal, like that. To do so manually, you would have to go up into one of these menus and find the superscript, subscript options, like these ones.
Just put on search button at the top, writing subscript. It's also, yeah,
In the top?
Yeah,
Search
above,
above. Which search?
on the middle bar.
On the middle bar.
No, just go up,
Up.
up.
Oh, this bar.
Yeah.
Yeah, I never use that bar. It's not even there for me. Yeah, so there you go. So that is a little bit tedious. The equation editor can make it easier. So if I do Alt equal or insert equation, then I type Y, then you use underscore to set up subscripts, and then when you hit the space bar, they look like that. Also, if you want to have Greek letters, like that, slash, and then the name of what you want. So if you wanted like a capital beta instead, like that, then you'd get, whoops, back, one of those. There we go. So little things like this will make your writing look more professional, making sure you get your subscripts and your superscripts right. Otherwise, it could be confusing to your reader. So happy to help with that as need be. All right, there, we're back at the beach. Not quite yet, but maybe in a few weeks, right? Any questions on any of this? So I wanted to just briefly talk about a question I had in office hours yesterday that I thought I did not do a good enough job making this point during the semester, so I thought, well, better late than never, right? So IRT, CFA, all of these methods are designed to provide empirical answers to questions about dimensionality and reliability. Do I have one factor or do I have two factors? How well are they measured? Those sorts of things. We end up with item parameters that tell you, that align people in terms of their trait estimates along with items in terms of their difficulty estimates. But beyond that, it can sometimes be difficult to convey to someone what is the benefit of this methodology. So let me give you an example, a real world example. My son, of course, whom I talk about all the time in his third grade class, he has a benchmark for their math tests that by the end of the year, he's supposed to be at a 210 on this measure. And we had parent-teacher conferences, and the teacher was very apologetic because unlike, number of words read per minute, which is very much an understandable outcome, she's like, I don't really know what 210 is. I just know that that's the benchmark. And so my son, like, well, what is he? Oh, he's 208. Okay. My first question would be, what's the standard error on that? Because if it's a standard error of 1, I'm much more concerned that he's below than if it's a standard error of 10, in which case it's all interchangeable. But more to the point, if he's not where he should be, how do I help him? Like, what doesn't he know that he should know? And just 210 doesn't tell me that. The fact that the class average is, let's say, 200. Okay, so he's above average maybe, but that still doesn't help me help him in terms of what he still needs to learn. This is where something like an IRT scaling can be very, very useful. So let's say that they pick a different scale for theta rather than mean 0, variance 1. They pick a scale in which, the mean is 200 or whatever. Like, you can pick whatever numbers you want. Then the answer to the question of what can't he do yet lies in the items of comparable difficulty. You would want to go to give me an item whose difficulty level is 210. The benchmark is your child has a 50-50 shot at getting that kind of item right, of that level of difficulty. That should be the goal. So then the question is, which questions did he get right? Which ones did he get wrong? And where are we relative to that item content? So what does a 210 look like? It looks like success on these items and failure on these items. That to me is a much more direct answer to what these trait scores mean than just, well, he's above average. Because ultimately it doesn't matter to me if he's above average relative to his peers or below average. I just need him to know what he needs to know to finish the third grade. So I don't know what he knows. I know that he has a score, and it's not the score they wanted. That's all I know. The same thing with, the how to be mean to your child example, right? Like if someone has a theta estimate of this, it's like, well, then there's a 50-50 shot that this happened to them. Like an item of comparable difficulty can help contextualize what these numbers mean. Because the numbers ultimately don't mean anything. They're arbitrary scales for an imaginary variable. But the tie to the items is a very useful thing. And you do have some of that, by the way, in CFA. On your reading list this semester, there's one article that I really like. It was in the CFA unit. It's this one, Fernando. He developed analogous indices of difficulty and discrimination within the CFA model. So like the difficulty of an item rather than an intercept. And I thought that was very clever and useful. So I would point you towards this one if you're interested in the ties between these things and how to think about it. This is also where I got the formulas for when your predicted outcome is expected to go out of bounds. That was in the same spreadsheet with all of these other computations. So lots of articles here. Lots and lots of articles. All right, how are we doing? Slight nods. Do you want to see a structural equation model? Like, well, I registered for the class, Lisa, and it's the last Tuesday, so damn well better give me a structural equation model at some point. How about that? Example 9. We'll do that one. These are the backstory of the dissertation model that I told you about a couple weeks ago. I'm going to walk you through the process of building to the grand finale structural equation model, as well as how to add in some extra stuff, and then examples of what you can do when you can't do SEM, because you can't make everything estimate all at the same time. So there are 2 publications that came out of this. I'm going to focus on the results that were reported in the second one here. So in these models, the first step is to make sure that all of the measurement models in the story are fitting adequately, and then proceed to the structural equation model. So the same is true as usual. Let me give you a sense as to where we're headed. The picture. This is my picture. M+ drew this picture and I rearranged it until it didn't look terrible. So what I have is age, which is eventually going to predict a latent factor of attention. It's also going to predict a latent factor of visual impairment. So these are all scored, by the way, that higher scores are worse. These are all like impairment-oriented things. Measure of processing speed, and then a latent factor of driving ability in a driving simulator that is indicated by various measures of performance. So I need to make sure that the vision factor and the driving factor fit adequately before I try to put all of these things together. So we can do that part fairly quickly. This is a CFA analysis because all of these measures were either sufficiently continuous, or in 2003 or 4 when I was doing these analyses, you didn't have as many choices. So that's the backstory there. So the same input is used in all of these models. I am going to be saving factor scores, by the way, because I'm going to make a point of comparing the structural equation model to the observed factor score version to see how close we get to things. So step 1 here, I'm fitting a model for visual impairment, and I'm also going to be computing omega and factor score reliability for it. So this is visual impairment. I've named my latent factor vision. It's being indicated by far vision, as well as these 5 measures of contrast sensitivity. And note, I am identifying it using a marker item, because vision, as a latent factor, is going to get predicted by age. So it needs to be able to have variance left over, which means its variance needs to be estimated. Also note that I separated the indicators. The first indicator that's fixed to 1 for its loading is on the first line, followed by all of the estimated loadings on the second line. I had to do it that way because when you label parameters, it's expecting the parameter to be estimated. You can't label something that's fixed. And I needed these to be part of the omega. So I separated it onto a separate line of code so that L2 through L6 refers to loadings 2 through 6 for this. I've got all of my intercepts written out, all of my error variances written out so that I can label those. Factor mean is fixed to 0, and then I have my factor variance labeled and estimated here. And then omega, and this is demonstrating the piecewise version of how to compute something. So I created one new term for the sum of the squared loadings, a second new term for the sum of the squared error variances, and then I left a placeholder for any covariances to remind you that it's twice the sum of those in your model. And then omega is the factor variance times the sum of squared loadings divided by that plus the sum of the errors and the sum of the residual covariances as well. Okay. So can I test fit on this model? Do a little vocabulary review. Can I test the fit of this 6-indicator model?
Yes.
Yes, because it is what kind of identified? Under, just, or over? Over, yes. The backwards terminology, over-identified, meaning that I have degrees of freedom left over. I have not spent everything that I could have. How many degrees of freedom did I spend? How many parameters am I estimating? $18, yep, 6 indicators times 3 each. 6 loadings, 6 intercepts, 6 error variances. How did we do? Look, it's non-significant. Yay. However, before I get too excited about that, what might I want to keep in mind? How much power do I have? I got like 150 people, so not very much power. So I don't have a lot of power to detect misfit at this sample size. But I collected every single one of these data points myself, so I'm like deeply invested in these 150 people. That was my entire summer from April to like August of 2003. Driving to the med center an hour away to get people in the driving simulator every single day. Yep, good times. RMSEA is a little bit noisy, but not different than 0.05, so I say wins. CFI and TLI, what do you think? Are they happy? By conventional standards anyway? Yeah, those are pretty good. SRMR, also happy by conventional standards. My average correlation is only off by 0.04. Here's my output. Of note, I am using the output to compute 2 different kinds of reliability. One is omega, which is reliability for a sum score. So if I were to take these items and add them together, that is the anticipated reliability that I would get based on the results of this model. If I were to output predicted factor scores, so they're known as EAP estimates, they are estimates of central tendency of each person's factor score distribution. The formula for that is the variance of the factor divided by that plus the standard error squared for the factor scores. So that is going to be a little bit higher, but still not perfect. So when you output factor scores to do something else with them, you have to keep in mind they're not perfect. There's still error to them, especially when you only have 6 items. But this is a CFA model, which means there's only one standard error that is assumed to hold for the entire sample, regardless of their latent trait of vision. Constant reliability due to a linear factor model. All the loadings seem okay-ish, not super strong, but you know, it's fine. Local fit, so using normalized residuals to look at standardized estimates of how far off each of the elements is in my variance-covariance matrix. These are in covariance matrix, I believe, covariance metric, I should say. So, this is, oh, no, these are normalized, excuse me, forgot which one I'm looking at. That's the highest one, well within an expected z-score type distribution, so I say it's fine. Next up, we have driving impairment. So this one also has 6 indicators set up the same way in terms of having one indicator as the marker so that I can fix its loading to 1, estimate the factor variance, and I have in this one, 1 error covariance. So 2 of the indicators need to be related beyond the latent factor. Speed is how long it took them to complete the course. Time is that. Speed is the number of fake speeding tickets they got on the course while they were doing it. And it turns out that if you speed, you get somewhere faster. So this is an example, I know, like who knew, right? Learning all kinds of fun things today. Yeah, if you run red lights and you get speeding tickets, you can maybe get somewhere faster if you don't get caught. But there was no cop to pull you over in this simulator. It was more of an attention check because they varied the speed limit and were watching to see if people noticed or whether they were just going to keep speeding along. Kind of like when you hit a school zone. One of my only speeding tickets. I'm like, what? I'm doing 30. Like, how am I speeding? Oh, it's the school zone's 25. Anyway, this one has a negative residual covariance, by the way, because they're inversely scaled. And I note this particular analysis is missing 20 people. So there were 20 people who did not complete the driving simulator task. They got motion sick. And I am also susceptible to that. I can't play Mario Kart or any kind of video games where it looks like you're moving through space. Like it physically hurts me. But most of them tried and started feeling sick, and I was like, oh, please don't yak in the car. Please just, no, just, you're done. Missing data, you're done. There was one or two gentlemen who insisted on finishing it with like a trash can in their lap because they was like, I drove fighter jets for the Army. I'm not gonna drop out of this. Like, it was offensive to them to even suggest it. It's like, okay, dude, like, you signed the consent form. You can drop out at any time. Please don't yak in the car. So 20 people. I'm not going to say it's missing at random, but I don't know what causes people to get motion sickness or not. If I could figure that out, I would be very rich. And I would use that technique on myself to be able to not get sick in the car or in shuttle buses or fun places like that. All right, so this model then, RMSEA is around 0.067, another wide confidence interval, but not different than 0.05. CFI and TLI are a little more equivocal. There's not a lot of strong correlations among these items, though, as we will see in just a minute. Standardized loadings, down here. What do we think about the scale of those? Standardized loadings, these are effect sizes, right? These are correlations of the factor with each item. I'd say they're not super great. But look, my model fits. It's not worse than perfect. So keep in mind, fit means that you have reproduced the relationships in your data. It does not mean you have relationships worth reproducing. That's effect size. So yeah, it fits well, but there's not really a lot of information about this latent trait, and that shows up as an omega of only 0.5, which is one of the lowest I've ever seen, considering we have 6 indicators, and a factor score reliability of 0.7. So not great on this one, but it's a behavioral task, and I was grasping at straws. So we still have divided attention wants to be correlated with the time it took to complete the course, but I don't have a theoretical reason to expect that, so I'm going to leave it alone. Next one, attention, has 3 indicators. And so I skipped all the stuff pertaining to model fit. Why did I do that? To save paper? Clearly that's not a problem for me. This is a 13-page handout, nowhere near my personal best. Yeah, it's just identified. Fit is not testable. I have 3 correlations between these items. I can fit 3 factor loadings, and it's a 1-to-1 correspondence, so I can't be wrong. If I wanted to test it, maybe I could put some constraints on there, but I'm not worried about that. I did this to make sure that I could compute reliability to demonstrate corrections later on. So omega for 3 indicators is 0.7, factor score reliability is around 0.8. Standardized loadings, mid-ish. Okay, now we're ready. So this is model 4A that is going to fit this thing. To do this, you need to learn one new word. Just one. It has 2 letters. The word is on. That's it. You've already learned by, which sets up factor loadings, and you've learned with, which sets up covariances. You need on. Can you guess what on is going to give you? I know you know. Some of you do. Most of you maybe. What does on do? Starts with an S, SL, O, P, E, yeah, slopes. Yeah, ons are slopes. Otherwise, in this context, they're called paths. They are called direct effects also. And if this were a DAG, what do they call them? Is this an edge? Is that right? What is it? Directed acyclic graph? Yeah, we're going to rename some more shit, okay? So it's an edge, a slope, a path, or a direct effect. On. O-N, that's what you need. In Lavon, it's the one squiggle by itself. So this honestly is the easy part, because once you have your measurement models built, it's just a question of how you decide to connect them. So an arrow going from a box to something else is a slope coming from the predictor to the outcome. Two-headed arrows, those are like error covariances. So it's whatever's left over in attention gets to be related to whatever is left over in processing speed. Diagrams like this usually go from top to bottom or left to right. I'm kind of doing a little bit of both. So the story here is age, chronological age, which is a box, not a circle, is going to predict vision, which in turn is going to predict driving. Age is also going to predict attention, which is going to predict driving. Age is going to predict processing speed, which is going to predict driving. And I thought that the ones in the middle would be correlated. Instead of predicting each other, that's a choice. And ignore this box right here for now. Now, why is age in a box and not a circle?
Because it is observed.
Yeah. Should I have made a latent variable for age? I could have one indicator that's like, how old were you last year? And then how old are you this year? And how old are you next year? Right? I could turn it into latent age if I wanted to. If I were assessing something like, how old do you feel? That's a different type of question, right? Like, how many of these body parts make noise when you try to get out of a chair? How many of your knees work? How much shorter are you than you used to be as a fully grown adult? Like, these are latent indicators of aging, but no, I have their birth date. I don't need anything else, the end. So the point that I was trying to make actually is that age ain't nothing but a number. I'm putting it in here as a straw man argument to see how little it contributes to the picture after you control for functional abilities that are correlated with age. That's my point of view. So here's the setup. First up, we build all of the measurement models. You already know how to do this part. You're just doing them all at the same time. So I've got vision, driving, attention. Now I'm doing this one for convenience sake. You have not seen something that looks like this yet. Processing speed was one observed measure, and I am making it a perfect indicator of a latent variable and shutting off its residual variance. That way, in the picture, it looks like I have my structural relationships with all the circles here, and this is a measurement model that only has one thing in it. Had I had an estimate of reliability, I could have used that to correct this information and try to tell it how much of its variance should go up to the latent trait. Reliability is like the proportion of variance that's true, right? So I could fix the path to be that much, and then I would know how much variance is left over as 1 minus that times the variance of the variable. I'll show you that in a couple models from now. But this is what is known as a single indicator latent variable. It is not different. What I have done is take all of the information in that box and moved it up to a circle. 6 of one, half dozen of the other at this point. Okay, here it is. 4 lines of code. Congratulations, now you know how to do a structural equation model. I told you it would be anticlimactic, didn't I? Our new friend on. And for those of you in the other class, you're like, hey, this looks like a path analysis. Yeah, structural equation modeling is path analysis with latent variables. So the fact that vision, attention, speed, and driving are latent variables is immaterial in terms of the code. I have defined them up here, so now they're able to be predicted or to become predictors. So these are all outcomes of age. So think of on as an equal sign. Y equals X. I am labeling the 4 relationships of age predicting each one. I am then having vision predict these 3 as well. I have a residual covariance between the part of attention that is left over after being predicted by age and the part of speed that is left over. So this would be like a disturbance covariance, technically speaking, but it's still the idea of leftover parts being related. And then attention and speed predicting driving as the last 2 parts, which I've also labeled here. In my original study, I did not care about mediation, but to build this example, I pretended to. So I want to show you how to get indirect effects, which we have not yet talked about, but you may have had exposure to. It's the idea that a relationship between 2 variables is in part due to something else. So you can assess the impact of how much is due to something else. So I made 3 indirect effects here by literally multiplying the paths. So age 1 is the relationship of age predicting vision, as defined and labeled right here. Age 3 is age predicting processing speed, and age 2 is age predicting attention. And then the second half, Vis 3, is vision predicting driving. Speed 1 is speed predicting driving, and then attention 1 is attention predicting driving. So indirect effects from age through these things to get to driving. There are various ways in M+, in particular, to get indirect effects, but this way works no matter what kind of model you have. The built-in indirect effects do not work for generalized models or multi-level models, but this technique does. So this is a nonlinear combination because I'm literally multiplying the 2 paths together to build the indirect effect. Okay, so this turns it into a structural equation model, but you've done the hard work already of building each of these latent variables and making sure that its items behave the way you intended. Questions on any of that? Nope. Okay, so then looking through the results, same process, 58 parameters being estimated. We got a lot of stuff going on at the same time. We get our HO model and our H1 model. Throwback, which one are you? Are you the HO or are you the H1? Yeah, us, we're the HO. That's ours. So then how much worse is our model than perfect? That one's done for us as the chi-square test of model fit. 110 degrees of freedom. That's how many more things I could have estimated but didn't. Most of that is from the measurement model. If I look back at the picture, how would you describe the structural model with respect to identification? Under, just, or over? Did I overlook any pairs of latent variables with age or each other at the structural level? We had a vote for just, changed to over. Everything is connected to everything else by either a directed relationship, path/slope/direct effect/edge, or a 2-headed residual covariance relationship. Structural model is just this part, it is just identified. It's as good as it's going to get. This model is going to perfectly recreate the correlations among these latent variables, but it's doing so in a way that aligns with my hypotheses about which effects should be unique after controlling for whichever other ones. So that means all of this information about how well this fits is about the measurement model. All of it. Structural model is just identified. And it is reasonably happy. RMSEA is down to 0.04. It likes parsimony. We have 110 things we could have added but didn't. Model itself is significantly worse than perfect. CFI and TLI are not great, but they're serviceable. Probably because the relationships are not that strong, so trying to find a difference relative to not that strong is a little bit more challenging. SRMR is okay too. All right, 144. That means you'll have to come back on Thursday to see the exciting conclusion of what happened if you get old and try to drive. I'll tell you what happens in case you can't come. Age doesn't do anything in this model. It's all about ability. Vision and attention are doing the lion's share of the work. So, but we'll get to that next time. And then, because I'm me, and I can't ever leave well enough alone, I'm going to show you how to do a latent variable interaction too. What? That's a thing? Yeah. I can make circles interact with each other, and I can get simple slopes out of them. Because I couldn't let you go a whole semester without teaching you an interaction term. That is not my brand. We'll do that on Thursday, okay? Okay? Okay, all right. Any questions before we wrap things up for today? Zoomers? Okay. Well, let me know if you need anything. I'll be on email. I know several of you have sent me stuff about your homework. I will try to get there as soon as I can. Office hours tomorrow as usual, and I hope to see everyone Thursday. So, thanks for being here. Hang in there, folks.